In this video, we will be discussing the distance formula, what it is, and when you should use it. So the distance formula calculates the distance between any 2 points. So typically we use this formula when we're given 2 coordinates. Okay, so before we kind of get to that formula, let's look at the diagram to the right and let's think about the next 3 questions. The first question says, how can we find the vertical distance without counting? So if you look at this right triangle over here, we know that our right angle is here, and I want to know the vertical distance without counting. So this would be our vertical distance here. One way of doing it is looking at the y-coordinates. Notice that the y-coordinate is the only thing changing. So we could subtract the y-coordinates to get our vertical distance. So 10 minus 4 would give us 6. That would be our vertical distance. Then how can we find the horizontal distance without counting? Same exact method. The only thing that's changing here is the x-coordinate. So we would subtract our x-coordinate, 6 minus 3. So our horizontal distance would then have to be 3. Now the third question says, can we find the diagonal distance by counting? Why or why not? Now this is a little bit more challenging if you try to count because it's kind of on this slant, so it's not as straightforward. But if you notice that you have this right triangle here, back to the last section, 9.4, anytime you have a right triangle and you know 2 of the sides, you can always use the Pythagorean theorem to find the third side. So we could go ahead and do that without counting, just simply using the Pythagorean theorem to find that distance there. So I'm going to go ahead and do that. I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus 6 squared equals our hypotenuse squared. So I get 9 plus 36 equals c squared. So then we end up getting 45 equals c squared. When I take the square root, I can simplify that. 9 times 5. So I would get that distance would be 3 square root 5. So that would be the diagonal distance. This method that we just did can actually be used to find any distance between 2 points, regardless of whether the distance is horizontal, vertical, or diagonal. So a formulaic way to think about what we just did would be the distance between any 2 points is going to be equal to the square root of the change in y's squared plus the change in x's squared. So essentially what I have underneath that square root is the Pythagorean theorem. And then lastly, we have to take the square root. So the distance formula comes from that Pythagorean theorem. So we're going to try some examples on the next page. So this first example is a very straightforward example of the distance formula. All you have to do is just kind of plug your numbers in. So you could call this x1, y1, this x2, y2, and we know that the distance between any 2 points is equal to the square root of, and you would subtract the y's. So if I do y2 minus y1, and then square that, plus x2 minus x1, and then we would square that quantity. And then I'm just going to go ahead and simplify what's underneath the square root first. So I know that negative 12 minus 8, that would be negative 20 squared, plus 5 minus negative 3 would give me positive 8 squared. So I get 400 plus 64. And then I need to take the square root of 464. And I can reduce this square root. So I get 16 times 29. And the reduced answer would then be 4 square root 29. So that's your final answer. Always reduce the square root if you can. So that's a very straightforward example. So what I'd like you to do is kind of using that distance formula, try the next 3 examples on your own, see if you can get the final answers, because these ones are a little bit more challenging. and then press play when you're ready to check your answers. Example 2, it asks you to find the perimeter of the triangle. So we know perimeter means adding all the sides together. So you just had to use the distance formula 3 times to find the distance between points A and B. So that's the length of segment AB, 3 root 5. The length of segment BC is 2 root 5. The length of segment AC is the square root of 65. And we can add these two together. So if we add them together, we get 5 root 5 plus the square root of 65 as the perimeter of that triangle. Just make sure you labeled the points correctly. Okay, then in number 3, this one's a little bit trickier because using the same triangle, it asks us to find the length of the median from A to BC. So you really have to think about what points would you need to use to find the median. So the 2 points that you would need to use is point A and then the midpoint of BC. Those are the 2 points you would need to find the length of the median. So we already have point A, but then to find the midpoint of BC, recall the midpoint formula. You have to add the x's together, divide them in half, add the y's together, and then divide those in half. And you get the midpoint of BC to be 1, 3. And then use point A, -4, -2, to do the distance formula for that median, and I got the square root of 50, but I reduced that square root to 5 square root 2. So that's the final answer that you should have for number 3. The last one, example 4, asks you to find the circumference and the area of the circle whose diameter is shown. So first we want to find the length of the diameter using the distance formula between the 2 points given, so that would be 3, 0 and -1, -4. I found that the distance, when I simplified it, I got the square root of 32, and that simplifies to 4 square root 2. So that's the diameter of the circle. So then to find the circumference, we can use the formula pi times the diameter, and you're just going to multiply then 4 square root 2 times pi, and you can leave your answer like this, as 4 pi square root 2 as the circumference of that circle. The area of a circle is pi r squared. So first I had to find the radius, which is half the diameter. So I got the radius to be 2 square root 2. That's half of 4 square root 2. And then you need to square that. So I showed my work here. Be careful when you're squaring a square root. Always write it twice. So you get 4 square root 4. That's the same thing as 4 times 2, which is 8. So your final answer for the area of the circle is 8 pi. Okay, so hopefully now you have a better idea of when to use the distance formula and how it works. Remember, it comes from the Pythagorean theorem, so we get it kind of from the idea of drawing that imaginary right triangle to find the length of a diagonal segment.